Sometimes when we're using raster data, we need to resample it. So resampling is typically associated with some sort of change in resolution, although it could just be some sort of offset in two grids that we're trying to compensate for. But let's take a look at this example here where we start out with 30 meter by 30 meter grid cells, and we want to put that for some reason, maybe for analysis with another layer, into 40 meter by 40 meter grid cells. So how do we do that? Because this grid cell contains mostly this purple, but some of this kind of lighter yellowish purple and the lighter purple. Well, we have to have some sort of rule in order to change the value from this grid cell into this grid cell, because we're starting out with 16 grid cells here and ending up with only 9 here. So one resampling method is the method that is associated with building pyramids, and that's called block resampling. And basically with this, the resolution of the new grid cells, fit within the bigger grid cell here. So in other words, these 4 grid cells fit into this one new grid cell here, so that we can use some very simple rules. For example, the majority statistic. That would just look at all 4 of the grid cells here, say 3 of these are purple and 1 is pink, so we're going to make this one purple. But if we wanted to, we could also look at the minimum value, the mean value, or the maximum value in order to do this sort of block resampling. The other sort of resampling method is something that looks like this, where we're trying to assign values once a new grid cell is put over, but we're not going to use block resampling because everything doesn't fit neatly. There's not 4 grid cells from the former grid that fit within this new grid cell. It's most of this one and pretty much most of this one and a little bit of this one and some of this one. So how do we get those values? Well, one would be the nearest neighbor value, and this basically just grabs the value from the old cell that falls at the center of the new grid cell. So that's why these black dots are here. They're the center of each grid cell, and this new grid cell here would take the value of its center point, which would be this yellow one. This new grid cell here would take the value of its center point, which would be the orange, and so forth. This is the fastest method. Not always the best method though, and it's usually used if we have categories or classes of data, such as if this was land use or something like that. We would typically use something like this nearest neighbor resampling. Another type of resampling is this bilinear resampling, and it calculates the new value from the 4 grid cells, or from the 4 values that fall closest to the center of the new cell. So once again, here's the center of the new cell, and the 4 grid cells from the old grid that fall the closest would be these 4 here, and it would use some distance-weighted formula on that. Basically, the ones closer by, like this one, would count more, and the ones further away would count less. And this is good with continuous data. And taking that another step further, the cubic convolution resampling, this also calculates a new value, but not just from the 4 closest neighbors, but from the 16 closest neighbors. So it's taking much more of the surrounding area into account, and it's still a distance-weighted algorithm, which means the ones closer count for more than the ones further away. And this one is definitely the best use for continuous data, and it's really the one I would recommend if you ever have to use resampling on elevation data. It's best to do this cubic convolution for elevation data. Even though it's the most time-consuming method, it's the one that when you get your new digital elevation model out, it won't have any artifacts from the old grid in it. So why would you resampling? Well, sometimes resampling is required, such as if you're doing a map projection from one coordinate system into another coordinate system, then it's going to be necessary to resample. And sometimes if you start out with a finer resolution grid and you're going up to a coarser resolution grid, you may also resample for that. But if you go the other way, if you go from something that's coarser to something finer, the thing to remember is that finer resolution, that's not going to improve your accuracy because the way that the data was collected was at that coarser resolution. So although you could always resample something down to finer and finer or smaller and smaller grid cells, it's really not going to help you because it's going to end up, for example, if we divided this into grid cells that were half this size, you're just going to get 4 purple grid cells instead of 1 big purple grid cell.